My name is Sheila Brown, and I'm the Executive Director of the Canadian Centre for Ethics in Public Affairs, CCEPA for short, which is a joint initiative of St. Mary's University and the Atlantic School of Theology. Our mission at CCEPA is to provide an arena for critical thinking, discussion, and research into current ethical challenges in society, which we do by sponsoring public presentations such as this one, supporting research, and assisting organizations who want to incorporate values and ethics into their plans and operations. Each year we deliver a series of lectures where participants can engage on topics of public importance. On behalf of our Board of Directors and our Chair, Alan Shaw, I'd like to thank you for joining us here tonight when we continue with part 4 of a 5-part national series, Trust in the Neurosciences. This series explores the ethical, philosophical, and social implications of the advances in genomics, neuroscience, and nanotechnology. Our speaker tonight on Mind the Gap, Neurosciences and their determination to explain the human, is Dr. Cornelius Borck, who will be introduced more formally in a few moments. The series is made possible by the collaborative efforts of the Canadian Centre for Ethics in Public Affairs and the Situating Science Knowledge Cluster. Funded by the Social Sciences and Humanities Research Council, the cluster is a 7-year project to promote new ways of bringing together leading scholars, studying science and technology from different perspectives, and make that work accessible beyond academia. Part 4 of this series is also generously supported by CIFAR, the Canadian Institute for Advanced Research, and the Evolution Study Group. We launched our series in this room last October, and we have continued thus far in Vancouver, Toronto, and Montreal. Here we are back to Halifax. You may view part 1, if you missed it, with Professor Nick Rose on the CCEPA website. And parts 2 and 3 are just being edited and will be up there very shortly. And tonight's presentation and number 5 will go up in due course. And speaking of part 5, we'll wrap up the series here in Halifax on Tuesday, March 30th, with a presentation on genes, genomics, and human nature with Dr. Evelyn Fox Keller from the Massachusetts Institute of Technology, who will also reprise her lecture in Edmonton. Tonight's presentation is being taped, so when we open the floor to questions, I will ask you to use the microphone, that one I assume, for the benefit of a good recording. There's nothing worse than watching a tape of something like this and all you can hear is a sort of mumbled question in the background and then the speaker responds to a question that you've not heard. So it is very important that you use the microphone, and we appreciate your cooperation. You'll also notice that round about you, maybe not exactly in front of you, are some evaluation forms. Your feedback is very, very useful to us as we plan our future events. So after you have completed the evaluation, we invite you to join us for a reception, and we'll be checking to make sure that you have done the evaluation before we let you into the reception, which is upstairs in the Peter Wilson Common Room on the 2nd floor of this building. But seriously, please do fill in the evaluation. And now I'd like to hand things over to Dr. Gordon McEwitt of the University of King's College and the director of the Situating Science Knowledge Cluster to introduce our guest this evening. Dr. McEwitt.
While walking around today on the waterfront with Dr. Borck, he reminded me that he was here once before. I forgot, and I was the one who invited him just like 3 years ago or so. And he ran a seminar for us with the Contemporary Studies program and the History of Science and Technology program on one of his sites of expertise, which is on Georges Canguilhem, the great philosopher and historian of medicine, French philosopher and historian of medicine. People might know him as the teacher of Foucault. And he was in the middle of he had just produced a book on Canguilhem, and also was helping us establish the Situating Science SSHRC Knowledge Cluster, and he was one of its original co-directors. He is visiting us from McGill, where he spends part of the year adjunct at the Social Studies of Medicine department, and was until recently a Canada Research Chair in the Philosophy and Language of Medicine at the Social Studies of Medicine Institute and the Department of Art, History and Communication at McGill, right? But his native Germany beckoned him back to the Heimat, lured him from those positions to head up the Institute for History of Medicine and Science Studies at the University of L琅beck. Not only is Dr. Borck one of the real upcoming, or really now well-established stars in science studies, starting at the University of Bielefeld and then at the Max Planck Institute for History of Science, where everybody that is somebody goes once in a while. Not only is he an upcoming star in science studies and the history of medicine, he is started as a trained physician, so what he will tell you is legitimate. His books on psychography, on neurosciences in the 20th century, on anatomical medicine, one of his earlier books, on representation, his papers on Weimar culture, on George Canguilhem, all are successful at situating science and medicine in its historical and cultural context and in its networks of representations, powers, and entanglements. Cornelius Borck.
Thank you very much, Gordon, for this kind introduction. I hope not to cut my umbilical cord while I'm delivering this lecture. As you can see from the poster, this is a repetition, and I also beg your pardon that I follow the humanities style of really reading a paper, though it will be accompanied by some fancy illustrations. Before I start, I want to thank in particular Sheila and Chris and Andrew and all the organizers. First of all, for making this possible, and even more so for welcoming me and hosting me in this wonderful way. Thanks. Brains lag behind. This observation was the fundamental scandal when Hermann von Helmholtz measured the velocity of nerve impulses some 150 years ago. Already by the standards of the 19th century, the nervous system did not communicate instantaneously, nor even very fast. Due to the mere signaling process along the nerve fibers, and regardless of the more opaque problems of attention or consciousness, human beings lag behind and miss out on the future. Since Helmholtz inserted the kymograph between signal and cognition, brain research has filled the gap between the two with vast amounts of data and knowledge. In fact, the technology has become faster than the brains observed. The instant it takes a human being to realize what her brain has received, the researchers' instruments have already sorted out what is still an unknown future to the brain and its inhabitant. Mind Time, as Benjamin Libet entitled the summary of his investigations, is the name for the period of processing it takes, so it seems, to create the illusion of a free decision in addition to the neurophysiologically already determined response. In light of the enormous advances and the fascinating insights, thanks to new investigative technologies such as functional brain imaging, the brain sciences appear to have come now very close to a definite understanding of their object. A few more details, some work on remaining open questions, and knowledge within the neurosciences will be complete, i.e., explain the totality of physiological events going on in the brain and the nervous system. This is what can be called the argument of prolepsis. Thanks to the recent progress in the neurosciences, the fundamental framework of brain and mind has been established. Certainly a comprehensive understanding is still in the future, but it can already be envisioned as it is within the hand's grasp. But should we trust this new science? Basically, my argument tonight will be, as long as the neurosciences do not come up with better and more convincing explanations for thinking and decision-making, there is no need to adapt to anything. In fact, it is of vital importance to human society to attend to the conflicting heterogeneity of insights from all branches of science and to not let one dominate. How then should we approach the neurosciences? About a year ago, a scientific paper shattered public confidence in this fancy branch of research. Voodoo correlations in social neuroscience. Already by its title, a title that eventually had to be changed for the paper's proper publication. So this is only the title of the pre-publication, but it was circulated widely under this title. This was a bombshell paper. In addition, its authors had done some clever public relations, had taken provision that most of the scientists accused of wrongdoings in the paper knew beforehand of its imminent explosion. What was the fuss about? Basically, the authors had taken a fresh look at the analytic methods of a sample of social neuroscience publications and had questioned the soundness of particular high correlation figures that had been reported between some form of social behavior and particular activation patterns in the brain. Social neuroscience is so fascinating precisely because it navigates back and forth across the nature-culture divide, linking socio-psychological indicators to brain activation. Looking into the reliability of each individual technique that forms part in such a cascading of experimental methods, the critics concluded that the reported combined correlation figures exceeded by far the maximum of the methodologically and physically possible. And here you can see that all those publications with excessively high numbers of correlations used faulty methods. Their fresh look at the analytic methods revealed that over half of the sampled papers, each little square stands for one's publication, used faulty techniques to obtain their results. So we better do not trust the new sciences than it seems. And did we scholars in the humanities not already know, even before this publication? We certainly shared some skepticism about maybe the neurosciences in general, but distinctively about functional neuroimaging. Didn't we? Come on, this is all we do. We always suspected. Finally, we have proven to be right. Unfortunately, it wasn't exactly criticism from our side that went into the paper.
It's been written by a graduate student in a cognitive psychology department. And I'm afraid the very fact that this paper has been accepted for publication and meanwhile been published gives the trusting science question a very different twist, as it now testifies to the very openness of this branch of science, even for radical critique. Isn't this paper a demonstration almost of Merton's mechanism of self-purification within the scientific endeavor at large? In effect, Edward Wooll's paper and the debate that it sparked now seem to provide rather strong and good reasons why we should trust science, shouldn't we? Such trust in the principles of scientific debate, however, would exactly not imply to readily accept scientific data and results as reported, but to receive them with healthy skepticism. As historians of science, we know that all data and all theories are up to revision as long as precisely these scientific principles hold. Trust in the new sciences. The title of this lecture series sounds morally charged and evokes a sense of obligation, as if, so to speak, on behalf of good citizenship, we should trust where science is going. The example of the Voodoo paper should have made it clear, however, that this is a problematic statement from the beginning. I want to suggest a different reading that takes the title, Trust in Science, as descriptive rather than normative. There is a surprising degree of trust in the new sciences. A degree of trust in the new sciences that exceeds the level of sober calculation, for example. Instead of either rushing to the voodoo accusation or, to the other side, the defense as mounted by the accused scientists, we should start with this amazing observation. An entire branch of scientific research collectively agreed to accept questionable standards of scientific evaluation precisely because the data and their interpretation were so promising, and they still are. The new visualization technique offers fascinating new views on social and psychological phenomena by looking into the brain, opening up for ever more ways of making sense of brain data. As a historian of the neurosciences, I'm intrigued by and interested in the ways how technology mediates access to the physiology of the brain and inspired mindful theorizing. This process has not yet come to an end. Far from it. We are just participating at yet another opening. This is the lesson I want to draw from history. We are experiencing the beginnings of an exciting new research field which, in all likelihood, will also posit tremendous challenges. But we are not witness to something like the ultimate or imminent elucidation of the human. In this respect, the neurosciences are perhaps somewhat in a similar situation as genetics a few years ago, when the Human Genome Project offered exactly this, ultimate elucidation. And that has obviously rapidly exchanged against a much more complex understanding of human genome and environment interactions. Even though most scientists are acutely aware of how many more questions every solved research problem generates, the narrative of discovery, as widely shared understanding of science, takes this, the discovery, the progress, takes this to entail its own teleology, eventually reaching its goal and closing debate. Even though the brain sciences advance at such a fast pace, this transformation is paradoxically regarded as ultimate breakthrough. This teleology is the problem. So society is probably well advised to take technoscience as a as a field of productivity, as a strategy to act and interact in complex natural, cultural environments, rather than as a final answer to pre-given questions. Before I return to social neuroscience towards the end of my paper, I want to bring this ongoing transformation into historical perspective by exploring previous technology-inspired brain theories. And I start in Canada with Dr. Penfield. Yes, doctor. Yes, doctor. Now I hear people laughing. My friends in South Africa. Yes, they are my two cousins. Patient JT lies on the operating table in the surgical theater of the Montreal Neurological Institute. His brain has been exposed in order to remove an epileptogenic focus, a spot of brain tissue where an old scar causes epileptic fits. He is fully awake, but not aware of the surgeon switching on the electric current, sending brief pulses down the stimulating electrode in his cortex, thereby reactivating involuntary memory, which the patient describes as more real than an active recall. Strangely similar to how Marcel Proust described the Madeleine. It was well known by then that electric stimulation of the motor cortex resulted in muscular movements in the opposite side of the body, and that there was a strict topographical relation between the stimulated spot in the brain and the responding muscle groups. And this is the famous homunculus of cerebral representation that you see on this slide. Wilder Penfield, however, extended this technique to other parts of the brain with even more exciting results. The issue was to determine the functional specificity of particular regions of the brain in order to save them during surgery. Penfield would open a patient's skull, expose the surface of the brain, and map its functional topography by stepping down point by point with his stimulating electrode along the brain's gyri, thus eliciting the respective physiological responses. For this, not only had the operating theater been converted into a special electrophysiological laboratory, as you can see on the bottom right photograph, but both the operating team and the patient embarked together on an expedition into new territory. The tip of the stimulating electrode acted as a voyager into the lands usually hidden not only inside the skull, but deep in the walls of the psyche. In Penfield's hand came the surprise when the electrode entered memoria, the lands of yesterday. Penfield perfected neurostimulation to a form of time travel, and there he found new media infrastructure. Penfield's electrical explorations resulted in the patient undergoing experiences of a forced déjà vu. Again and again, the stimulating electrode acted as a memory activator, bringing back a distinct recollection, not a mixture of memories or their generalization, as Penfield explained. From patient to patient, every detail of their life was being recorded deep down in their brains with the precision of a machine. The automatic operations of this memory system could best be described as the actions of a kind of tape recorder. However, this was a very special type of recorder that did not register the events as they occurred in the outside world, but from the internal perspective of the subject, as Penfield aptly described by differentiating the metaphor in terms of its technological validity vis-à-vis the experiential quality. I quote, "The subject feels again the emotion which the situation originally produced in him, and he is aware of the same interpretation, true or false, which he himself gave to the experience in the first place. Thus, evoked recollection is not exactly photographic or phonographic reproduction of past scenes and events." End of quote. The phonograph and the photograph were not quite the right tools here. But that's why they worked so well, because they captured precisely what memory was not, an objective representation of the outside world. The technology did obviously not determine Penfield's theory of memory, but it furbished his pursuit a powerful image. Later in his life, after switching his career from the operating to the lecture theatre, Penfield made a sketch connecting his experimental clinical observations with his more general philosophical ideas. In this sketch, a chain of metaphors bridges the anatomy of the brain and its interior parts to MIND, as you can read on the far left border of this slide. Mind situated far away from the hippocampus and possibly even outside of the cortex. The graphical symbol of the key of access connected the right and left halves of the brain, and lines formed structural as well as logical linkages from the key symbol to the different sections of the hippocampi, and from there through or under the cortex into the stream of consciousness. That was the mind. In this case, a kind of psychic video machine captured on its strip of film all experiences awaiting recollection in the form of active retrieval or forced recollection by means of electric stimulation. And just by the way, one should one day do a quick, nice little paper on the key as the object that's always been in the image, the key of access. When the brain or some of its functions are being compared to technological inventions, such as the camera, the phonograph, or the tape recorder, these models obviously stand in for specific functions attributed to the brain. Each of the models accentuates a particular aspect of the brain's operations. Yet, the historical sequence of different technological models which have been mobilized in order to grasp the brain's functional capabilities also characterize the investment in brain research for addressing the more fundamental questions about the nature of being human. For more than 200 years now, the brain has increasingly been mobilized as the central organ for addressing la condition humaine, investigating the arguments and ways in which particular models were adopted to explain the brain illuminates the complex history of this branch of research and elucidates how machines served for explanatory purposes inside and beyond the respective fields of technical application. In addition, it amounts to a rich and changing history of how scientists and the general public looked to the brain to answer vital humanist questions. Let me make this point clear here, particularly since I combine my argument with Fritz Kahn's fantasy techno-worlds of the brain from the beginning of the 20th century, where one may feel invited to smile at the naivete or the inconclusiveness of the technological solutions for particular aspects of brain work that, by the way, all require, in addition, these little human helpers and workers and attendants instead of the suggested automatism of the machine. I'm not saying these guys, the brain scientists or the popularizers alike, these guys got it all wrong and the machine idea is just out of the way. Quite the contrary. Machines and models offered intriguing ways to reflect about mind and brain. Compared to other branches of medicine or the life sciences, brain research has engaged in a particularly active dynamic with regard to metaphors and models. This resulted in an ongoing process of technological metamorphosis of the brain. In contrast, for example, to the metaphor of the pump that was consolidated long ago in the physiology of the heart, the brain appears to be an unstable organ that has been compared to a wide and variable range of objects. The argument that is typically brought forward for this heterogeneity is the intrinsic complexity of the brain as a natural object, whose very nature is apparently so much more than a simple single device. Such a naturalistic argument, however, is more difficult than it may appear at first glance and should hence be treated with some caution by the historian. Epistemologically speaking, the plain argument of anatomical design is not exclusively empirical and hence not naive. The complexity so easily assumed to apply to the brain is very much an attributed quality, reflecting as it does cultural expectation, the desire to invest the brain with the elevated status of delivering compelling answers about human nature and intelligence. Since the invention of the first automata, machines have been debated as models of body and brain fairly independently, by the way, of the underlying philosophical framework. This is, as shown here in the slide, most famously exemplified in the contrast between the dualism of Descartes' posthumous De Homine compared to the radical materialism of La Mettrie's scandalous essay L'Homme Machine, while both conceived of the human body as a machine. And this could be untangled as a proper argument that there is no intrinsic reductionism in the machine theory per se, and its historical trajectory points rather to a complexification of the story. In addition, technological models did not have a monopoly in the discourse on the nature of the human body, and our current interest in blurred boundaries between man and machine must not obscure the historian's awareness for the fact that alternative arguments also attracted widespread attention, and that's why we now go. For many brain researchers of the early 20th century, for example, it was out of the question that mind or brain should be meaningfully compared to a mechanical machine because of its categorically different biological nature. This argument gained momentum after the publication of evolutionary theory and with discoveries in cellular biology. As a consequence, researchers revised older ideas of a unique and universal biological principle, such as irritability or movement or appropriation, and created from them a remarkable psychobiology, linking highest mental functions to the most basic but specifically biological properties that could be found in primitive cellular organisms such as amoeba. In addition, such a theory was very well suited to explaining learning and adaptation phenomena chronically difficult to account for with a machine metaphor because of a lack of appropriate tools. Among the proponents of such biological models of cognitive action counted a number of prominent neuroscientists, among them Santiago Ramón y Cajal, Auguste Forel, or here Theodor Meinert, whom I will now go into just a little bit. Initially, Meinert had argued for the perfection of the brain simply on basis of its geometrical shape, linking the shape of the brain to the sphere that already Plato had identified as a form of perfection. To this, he then later added this new fundamental insight of psychobiology as an active functional property. And so we arrive at his brain theory, I quote, which is a theory of thinking, basically. I quote Meinert, "Just as the medusae," he's speaking about the brain, "just as the medusae stretch out their feelers into the world and take possession of their prey through tentacles, so this composite protoplasmatic being, which is the cortex, possesses centripetally conducting extensions, the sensory fibers of the nervous system, which we may consider its feelers, and motor fibers, which are its tentacles." End of quote. For Meinert, the concept of ideal shape and the idea of a protoplasmatic action of nerve cells did not serve as merely rhetorical tools. This is important in my view here. Mere rhetoric explaining otherwise well-defined physiological action. Quite the contrary. Only by the use of the metaphoric model, Meinert was able to make sense of his anatomical observations. The metaphoric model furbished epistemic significance for brain theory. And in fact, the model also sparked further anatomical investigations, which led Meinert to deviate from the main course of anatomical dissection and slicing techniques in the later 19th century. Meinert insisted instead of this careful preparation technique with which you can actually follow through the fibers through the brain. You would lose these connections by slicing through. While Meinert escaped mechanical analogies for the brain, others used mechanical tools, as we have heard, in order to specifically highlight differences. Penfield with the differentiation of memory, human memory from phonograph. In this way, a model could be utilized as an analogy together with a differentia specifica in order to demonstrate typically the superiority of the brain above the tool it was compared to. In a similar tradition, the brain has been compared with various instruments of wonder, such, for example, musical instruments. The most famous of these comparisons, however, is not a musical instrument, but obviously Charles Sherrington's Enchanted Loom. I quote, "Where millions of flashing shuttles weave a dissolving pattern always a meaningful pattern, though never an abiding one. Sherrington modeled the brain on what was then technologically a most complex machine, the Jacquard loom. The master, however, of the strategy of explaining the psyche in technical terms, but beyond the physical space of any technological model, was Sigmund Freud, arguing that the realm of psychic processes must not be conflated with the physical space of the brain's anatomy. Freud broke with both the reductionism of machine theory and the monism of psychobiology, thereby transforming the traditional ontology of Cartesian dualism to the epistemology of his psychoanalytic theory. As a well-versed writer and with a solid grounding in 19th century neuroanatomy, the neuroanatomy of his teacher, Theodor Meinert, Freud used analogies and technological models for elucidating the flaws of any naturalistic theory of the brain and mind. He mobilized models and metaphors precisely as imperfect tools, as can be studied in his many strategic comments on the limits of particular visual metaphors or functional analogies. A famous example is Freud's comparison of the psyche with the city of Rome in Civilization and Its Discontents from 1930. The point of comparison is not the large number of ancient buildings, nor their existence to this day, but the very non-imaginability of a Rome that has been preserved in all its building ever built. Such a city may be thought of, but can no longer be visualized. In order to gain clarity on its significance, the analogy had to be driven beyond the limits of visual representation. I quote, "Our attempt seems to be an idle game. It has only one justification. It shows how far we are from mastering the characteristics of mental life by representing them in pictorial terms." End of quote. Freud developed a visual argument that the psychical apparatus can only be described in language and not represented by anatomical visualizations, because in his theory, the psyche followed the structural logic of a symbolic space and not the anatomy of a geometrical topography. Whatever the brain does, the psychical apparatus is a peculiar system for Freud for receiving, storing, reactivating various kinds of traces written on its surface. The psyche is an inscription device. While Freud speculated about writing as a primary psychic action, electroencephalography allowed the brain to literally inscribe its activity onto paper. The human electroencephalogram had first been published by Hans Berger in 1929, but brainwaves emerged only a few years later as a scientific object when Nobel laureate Edgar Douglas Adrian demonstrated Berger's experiment to the astonished Physiological Society in Cambridge in 1934, showing not just some basic brain physiology, but a perfect recording of mental activity. In this case, Adrian's mental activity. We don't have a recording from that memorable moment, but we have a similar recording. We have the original description by Gray Walter, and we have a similar recording from Hans Berger when he did more or less the same experiment on his daughter Ilse. We see Ilse lying on the chair in the top recording. Why is this not working? It is. That's not. It's too dark. So the big wave is the EEG. The very regular is just time. In the middle, you see Ilse calculating in her head 5/1/5 times 3/1/3, and you see that her brain has gone really active, wobbling out this calculation. The moment she comes up with the result, Ergebnis, her brain switches back into what we now call alpha waves, the resting mode. So that was the astonishment, a strictly physiological method that would nonetheless record changes that are correlated to mental activity. It seemed as if the world of brain structures, nerve fibers, electrical potentials would blend over into the world of meaning, sense, and life. Obviously, an irresistible opportunity for proleptic projection. As one of the observers of this experiment wrote, I quote, "Today, the brain still writes secret signs. Tomorrow, we will probably be able to read neurologic and psychiatric diseases in it. And the day after tomorrow, we will start writing our first honest letters in brain script." While the commentator hoped for the arrival of an enlightened age of epistolary authenticity by means of brainwave writing, others, including Adrian himself, were more cautious, calling attention to the rather disappointing stereotypy of the recorded responses. In fact, there was not that much of a difference between the brilliant brain of Adrian doing mental calculation than to the water beetle's ganglion just responding to light. Apparently, it costs no more brain than a water beetle's ganglion to be awarded a Nobel Prize. What may seem as an insult to human dignity can also be read as a message to his colleagues to mind the gap. Observe the limits and the method's limitations. I think here we come very close to the current hype surrounding neuroscience publications. The EEG and neurophysiology have certainly proved enormously important for understanding of mind and brain, though they did not deliver what the contemporaries expected them to do. BrainScript has not become a reality, at least not yet. But brainwave recording paved the way for the most important and powerful media technology as analogy of the brain's doing. And you all know what I'm talking about, the computer, the thinking machine. When machines became available that used electricity for logical operations and calculation, the gap between the world of material processes and symbolic action appeared to be closed, and brains had become computers. From this moment on, for the rest of the 20th century, brains were discussed as biological object instantiations of such machines. Henceforth, there was no divide anymore between physical, biological, and psychological processes. And again, the computer proved to be an enormously important tool both on the conceptual, just think of cognitive science, as well as the material level, to think of how little neuroscience would have done without computers in the labs. Although back then computers were still immobile, garage-sized technological systems that did not physically resemble the brain, they quickly dominated brain theory. According to Norbert Wiener, for example, brains resembled computers not only with regard to their calculation capabilities, but even in that they used a similar mechanism for data processing. And he cashed out his theory at the MIT, having at his disposal the then the most powerful computing technology for sorting out his own brainwave patterns, as you can see him doing here. Computers, that was Wiener's conclusion, use electricity for their operations just as neurons communicate by electric impulses. That physiology had already determined. And similarly, there was also a correspondence between the all or none principle of the nervous signal and the 0 or 1 of the digital code. Whilst Wiener's idea did not really stand up to scrutiny, it was certainly not the last time that brains would be mistaken for computers during the 20th century. In fact, the comparability quickly resulted in a fierce competition between man and machine. But here, something similar to the implosion of genetics into post-genomics in consequences of the deciphering of the human genome happened with regard to the computer metaphor. Paradoxically, the victory of IBM's Deep Blue over Kasparov in 1997 did not cause a redefinition of the game, a repetition under different rules, or a selection of a better player, but made the hitherto deeply ingrained analogy between brain and computer look superficial and falter, coinciding, as it did, with an increasing awareness of the machine's clumsiness in doing something beyond calculation. For example, bodily movements. At the opening of Expo 2000 Hannover, the computer-controlled alien that was designed to welcome the German Chancellor in the opening ceremony fell on its way on the one and only step that there was. Today, only 12 years later, it is already hard to recognize and to reconstruct how it was that the computer so easily assumed the role of central metaphor in brain research over such a period of time. Maybe one day we will look back on the computer as the most convenient form and most common form of misunderstanding the brain in modern history. The computer, however, was not just one more step in a long sequence of models. In a certain sense, the universal logical machine was the ultimate model. At least up to now, it has proven irreplaceable. What newer tool or gadget could possibly replace the computer? What could stand in as the next central metaphor? Take the iPhone. It can be said to be much more versatile than the desktop computer, let alone its room-sized forerunners with which this analogy began. In addition, it symbolizes the trend towards ubiquitous computing, just as human beings have the option to use their brains wherever they find themselves. And nevertheless, the iPhone does not suit as the up-and-coming model of the brain because, in essence, it is just a handsome tool that ill fits the status of humans' mirror image. Similarly, the World Wide Web is sometimes said to be the brain's next top model. And it certainly has dramatically affected how we conceive of human intelligence. And yet, with its physical dispersion, the internet is too intangible to serve as a model in similar ways that the computer did. But the fading out of the central model may also have an entirely different reason. The decline of the computer metaphor coincided with a second, potentially more significant shift, the rise of a new visualization technique. Functional imaging currently attracts enormous attention among the scientific community and the general public because it allows the simultaneous visualization of structural as well as functional details, showing distinctively task-specific brain activation. Functional imaging, the recording of changes in the blood flow through the brain, started 100 years ago. This was an apparatus to record blood flow changes through the brain. Looking back at these recordings, from the point of view of current functional brain imaging, any interpretation of such traces appears somewhat far-fetched, to say the least. It is quite difficult to believe what conclusions scientists were willing to draw from so little deflections. Once all psychic states are investigated and their specific patterns characterized in the form of these single undulating lines, the plethysmograph will work out as a real psychoscope, an instrument for a reliable diagnosis of a person's dispositions. How could a simple and single undulating line possibly function as representational space for the entirety of psychic states? Instead of arguing for ignorance on behalf of the scientists involved back then, the historical conclusion from this parallel is that it is impossible to quantify the amount of information required for an allegedly comprehensive understanding of the brain. Today, we certainly know more about the brain. Much more do we know about the brain than 100 years ago. But there is no way to measure this progress in units of completeness. And here we are back to the problem of teleology. We certainly have progressed. We have progressed massively. But at the same time, we also know much, much better how difficult the problem is. In a certain respect, one could even argue that the researchers back then were right in assuming to be close to a complete understanding of the brain, given by today's standards, the back then rather limited conceptualization of the brain, of the problem to solve. Such a historically grounded skepticism may also shed some light on more recent exercises in proleptic theorizing. Taking deliberately the position of devil's advocate from the point of view of recent advances in the neurosciences, one of their robust and outspoken leaders, Christoph Koch, for example, describes the achievements of the humanities, compared to what the neurosciences have now done, as a blatantly obvious failure. I quote, "On the basis of the recent progress in experimental methods, Crick, the Crick of the Watson-Crick model, and me were able to formulate a conceptual framework of consciousness. This is still certainly preliminary, but the hypotheses derived from it allow us to interpret new observations and to design new experiments and hypotheses. The humanities, in contrast, altogether failed in developing a coherent strategy for solving the mind-brain problem, regardless of their heroic attempts over several centuries. The philosopher's instruments, introspection mixed up with logical reasoning, simply do not measure up to the complexity and inaccessibility of the mind. This is different for the neurosciences. In due time, science will identify completely the neuronal correlates of consciousness." End of quote. Since research in the neurosciences is expensive and requires public funding, boisterous statements sparking the public imagination must be expected from competitors for limited resources. But it does strike me here how the intrinsically contradictory nature of such a statement passes by completely unnoticed. Up front, Koch frankly and proudly indicates that his framework for consciousness is new and is designed to generate new hypotheses. And yet, he can't help but conceive of this opening of a new research enterprise, to conceive of this as a closure, as the imminent and ultimate dissolution of consciousness into neuronal correlates. How will these correlates connect with the arguments, ideas, practices in which the discourse on consciousness is embedded in contemporary society alone, or to how all these centuries that philosophers wasted by reflecting about the inexhaustibility of the mind, all these centuries reflected about something that we now would call consciousness. Even more startling and definitely more problematic than such a rhetoric of bold confidence, thanks to prolepsis, more problematic are the consequences Koch and his colleagues draw from such envisioned breakthroughs for today's society. I quote, "The results of the neurosciences will have consequences for the conceptualization of human beings and human society. Once the public becomes aware of them, we will have to face dramatic shocks regarding our self-image in the foreseeable future. Humanities and the neurosciences have to engage in a thorough dialogue for constructing a new and consistent image of man." That is the famous or infamous manifesto of the leading German neuroscientists from a couple of years ago. According to these neuroscientists, brain research will affect and indeed should change the world. The discourse of political decision-making, value judgments, personal responsibility will simply have to be adapted to neuroscientific insights. One may want to question whether this is a scientifically justified or morally legitimate or politically desirable solution. But much more troublesome is the striking ignorance on behalf of the neuroscientists with regards to the dynamics of socio-techno-scientific interrelations. The neurosciences will certainly affect contemporary society. We are just witnessing that. But this transformation, the beginning of neuroculture, unfolds as a much more complex process than just in the form of taking in yesterday's research results. Certainly, there are many ways in which the humanities and the neuroscientists could and should cooperate for generating data that will then affect human societies probably even more powerfully. For example, just last week, in a paper that has just been published a paper in calling for neuroanthropology as the proper foundation of a crossover between functional brain imaging and anthropology, using the expertise of the anthropologist for properly classifying the people who would then go into the scanner. This is probably a good way if one really wants to identify specific subgroups of human people vis-a-vis brain activation pattern. But there are certainly other branches of anthropology that function just by a different set of scientific principles, then subsume only to that which can be visualized in the scanner. So, alongside and next to such forms of cooperation, there are many more forms of scientific exploration and scientific debate. And any society should cultivate rather than harmonize such differences. Don't the sciences revolve just like the political realm around precisely difference, heterogeneity, tension, and conflict? Aren't these the principles of doing science? This skepticism from socio-political reasoning, and so to speak on behalf of political theory, is substantiated further by the dynamics of brain research itself. The single line of the plethysmographic recording forms the missing link between today's overwhelming visual evidence and earlier brain-based investigations into anthropological nature. Who knows how people in 100 years will smile at the current trust in false-colored brain scans as representations of the functional anatomy of empathy. The historical persistence of prolapses, the recurrence of the pattern of the almost there, seems to be as much the result of an overestimation regarding current progress as of an underestimation, not so much of the complexity of the problem, but of the very productivity of the neurosciences themselves. The productivity of the experimental technologies in the neurosciences constantly renews the open-endedness of research about the brain. Brain research has so far proven to be a highly efficient endeavor to increase the complexity of its object. Together with any advances in understanding the brain and perhaps the mind, this very research object had been made much more complicated. Rather than delivering an ultimate understanding of mind and brain, the neurosciences are complicating brains as their results move the horizon for a comprehensive understanding into the future. The history of the neurosciences must therefore be written as an ongoing transformation of the brain. With so many neuroscientists around the world working on the brain, the story will, and now I come to my end, the story will in all likelihood get soon more complicated. If anything, it is precisely the phantasm of an imminent elucidation of the mind-brain which limits this open future. As in neurosciences, productivity is anchored in the means to complicate the picture in unforeseen ways. They, the neurosciences, just become part and parcel of our human culture. And here, Louise Wilson's installation Possessed comes in. On the first layer, as I showed the slide earlier, it acts as a critical commentary on the current obsession with brain imaging by comparing it to a previous generation's engagement with psychoanalysis. Functional brain imaging opened a new chapter in the Functional brain imaging opened a new chapter in the history of brain research, the entry point of brainhood, the positioning of the neurosciences as a universal frame of reference for addressing human nature, just like psychoanalysis had done so a century ago. The available precision of spatiotemporal information regarding brain activation, however, facilitated a reification of different brain states by replacing the functionally abstract view of the brain as computer model with the concreteness of the brain at work. And here I see the major difference to the history of the brain as machine. Vis-à-vis the ready availability of task-specific brain images of brain activation, the older debate about shortcomings of particular models or the appropriateness of the machine metaphor in general appears to be nostalgic, and in a certain way nostalgically futile, pointless, now that the neurosciences can offer human societies brain images instead of machine models. The neuroimaging sciences engage the epistemological reductionist of materialist approaches, but at the same time increase ontological complexity by constructing ever more subtle substrates of emotional, social, cognitive states, until we forget about dreaming on consciousness, because all of these neuronal correlates brave neuro worlds. Models and metaphors may fail or betray, but they typically operate in and on a differentiality between the object and the concept. While images, as objectifying representations, always already tend to conflate the object with its representation. All kinds of fascinating brain images invite us to take false-colored pictures from the interior of thinking or feeling as an answer to our question of what thinking or feeling is, or how we should do it. Thanks to ever more perfect visualization and simulations, the artificial has become indiscriminately real, animated, and alive in the neurosciences. The neurosciences transferred life onto the screen with the slogan, "We are our brains." And here, the future challenge for the neurosciences emerges, as Wilson alerts us with the interactive part of her installation. The viewer is invited onto the couch, though not for the talking cure, but for listening to a voice calling her to relate to the brain scanning, to form a connection with it, and to touch it. Steps which then set in a playful way in motion a transformation of the image on the screen. Rainer Goebel recently reported about his fMRI experiments with a meditation-practicing Tibetan monk. Such experiments have a fairly long history, though obviously not in the brain scanner, because of the West's flirtations with meditation as the cultural other. So when EEG technology became cheap and robust, that was a very, very fancy and looked after meditation-enhancing device. And in the meantime, functional brain imaging has been perfected to a degree of expediency that in this case, meditation-related states of brain activity and the degree of a volunteer's focusing on meditation can be reported back in real time to the subject in the scanner, giving the monk immediate feedback about the success of his exercise. Certainly, these scanners do provide answers to cost questions for the correlates of consciousness, though that has become utterly irrelevant here. Here, they open a new way, the technology opens a new way of accessing and interacting with one's own perceptual realm. Right now, the first trial sessions are being scheduled for patients with chronic pain in the hope they may find new ways of connecting to relaxation-induced brain states where the pain input is being shunned. The monk simply decided to stay in the scanner. "This is so good," he said. I thank you.
Vielen Dank. I wonder if you would take a look or go on another band. I'm thinking of the work of Selye. Can you hear me? Okay. I wonder if you take another band and go in the direction of Selye and his the hormones, stress receptors, enkephalins and endorphins, endogenous as well as your NMDA and GABA receptors. In other words, a whole new field which you haven't explored to try explain, as he did, the stress of life without distress.
I did not talk about Hans Selye and his research on stress, though you're absolutely right, it would be spot on here. And I would use Selye as a case to develop or to demonstrate how models not necessarily sail by themselves. Selye's stress model simply suffered from the fact of being too general, of being an all-encompassing theory. At a certain moment in time, that was exactly what the field was after. The general adaptation syndrome, GAS, the core of Selye's theory. But soon, as this could be applied to ever more fields, the scientists themselves feel this to become a too vague theory. This is probably nothing to do with the theory itself, because it certainly was much more theory, much more neurophysiology in that theory than in just the idea of a feedback loop as the central unit of control that, under the banner of cybernetics, entices the entire world. But it would, comparing Penfield's tape recorder, Meinert's medusae, with Selye's general adaptation, or the idea of feedback, I think one would come to that would be a wonderful way of sorting out how in a particular time, how very general, very universalizing theorizing, or rather specific, tied into the specificity of the two forms of theorizing flourished and made sense to the contemporaries.
First, I found myself enjoying your talk. Thank you very much. I found myself thinking about Korzybski's phrase from 1931, that the map is not the territory, because you were providing many examples of maps or hypotheses or models, and noting that the territory of the brain may not necessarily match onto the map that we've got, so we have to be cautious about our maps. I'm still concerned about this a great deal, even in the neurosciences, because I think the territory is not yet well explored enough. A couple of examples. The reason Hans Berger developed the electroencephalogram was because of an experience his sister had. And for those in the audience who don't know, Hans Berger had his head nearly run over by a wagon pulled by a horse. The wagon had a cannon in it. His head would have been crushed. His sister, at that very moment, many miles away, had an experience that something terrible had happened to her brother. That provided a stimulus to do that. That's one example. Paul Pearsall writes about, in his work, the child psychiatrist who spoke about a parent bringing a child to him, or to her, and her need eventually to take the parent and the child to the police, because the information the child had about what a room looked like, about what was said, about what clothing was there, about who was there, about a murder weapon, provided the police with enough information to identify, for sure they believed, who murdered a 10-year-old girl whose heart was in the 8-year-old patient. He has many other stories like this. His work is in transplantation. I pull this one out because I think it's a good example. Or Professor Ian Stevenson's work, the Carlson Professor of Psychiatry in Virginia, who has spent 40 years taking a look at children who remember past lives. Fascinating work when you read the book. He examines every one of these stories, like today's analogy would be a CSI detective. Fascinating stories. And yet, we don't in neuroscience take a look at this kind of phenomenology. The closest we can get is when we start to take a look at people looking at consciousness, the mind, and aspects of physics, such as David Bohm's physics, or even the one that came in the newspaper just a few weeks ago, Craig Hogan talking about the universe being basically a hologram. These are people who start to explore this area. So it's fascinating. I appreciate your caution, and I'm adding, I think, more reasons why I think we still have much to learn.
Thank you very much. I think the opening with the mapping points exactly in the direction I want to go. I mean, mapping is obviously one of the most fascinating activity of mindful brains, and so my plaidoyer not to stick to too boring maps.
Yeah, I like the paper too. I like the defense of the humanities line you were taking, and the defense of heterogeneity and conflict as constructive values in assessing science practice. So great stuff there. I guess I was curious as to whether there is in what you're saying a tendency to either go to pragmatism or aesthetics in talking about these various ways of moving between model and objective research. I mean, maybe you just do the one that you think is prettiest. I mean, you could go for the one that you think is most useful for a particular function, but it does seem to me that there's an element of aesthetic in here, and so I'm curious in your comments on that.
You certainly got me on that. So I, some time ago, for quite some time, I tried to come up with a good story on the aesthetics of visualization in the neurosciences. But I got frustrated with that because I couldn't convince myself that I was actually forging a good argument. Though I am still convinced, just from my own practice in dealing with recordings as an electrophysiologist, it is just by inspection that I knew whether this was a day worth of experimentation or it was just wasted. I mean, even before we did the statistical analysis, just in this very down-to-earth way of that the eye is such a wonderful analytic tool, deciphering graphical representations. Though I do still work on in the field of aesthetics because I'm interested in the interplay of media and the senses. I take aesthetics as the domain of perception and how perception and ideas of perception and instruments of perception affect the way how we construct the world. And I do this at the moment rather vague hope that will open another avenue for the historical epistemologist, because it allows to align and contrast forms of experimentation with the senses, challenging, or making use of this notion of that the arts have become experimental in the 20th century, taking this rather serious, that there may be in the realm of doing art a particular potential of confronting human beings in their sensory apparatus with situations that may allow a particular way of reflecting about it that is interrelated to what happens at an important moment in doing science as well. So.
My question has to do with the fact that you describe the models of the brain in a chronological manner. I guess I'm asking your personal prediction on if you think that we'll continue to get to a perfect model using some specific type as computers, or whether it be something else, or if it's going to end up being a collection of all the models, if it's going to end up being being very collective of all our, historically, all the models that we've gone through.
Very good and very difficult question. I think as a historian, or as a skeptical historian, I'm somewhat doubtful whether we can regain the richnesses of times past. So, for example, I think it's no accident that we don't conceive of the brain any longer as an object of wonder and as a musical instrument, though that obviously has still very, very powerful resonations in our culture. So probably there has something been lost, so to speak. Looking into the future, I want my talk to be understood as something that, by its very nature, but also on basis of my epistemological as well as political principles, should not arrive at a conclusion. There's a wonderful and moving and challenging text by L· the Polish microbiologist and founder of social constructivism, that barely survived the Holocaust because he was a specialist on typhus, in being forced to produce anti-typhus vaccine in a German concentration camp. The very first text he published after being released from Buchenwald was a stated dialogue about whether scientific truths should be safeguarded and kept, or must always be debated and be open to discussion. And reflecting on what he has just come through, he writes this as a manifesto for permanent transformation, because that is the only way we gain both better science and human society.
I was wondering about your claim that the computer metaphor has been replaced by the functional imaging. And it struck me, at least I've been reading a lot of evolutionary psychology, and evolutionary psychology has this strong brain as a computer commitment, not just as a metaphor, but ontologically. And of course, they also have the modularity commitment. And it seems to me that the fMRI is picturing these little modules of activity, and you get the mechanism. And it seems to me there's actually an awful lot of crossover in the underlying ontological commitments of evolutionary psychology, and then the kind of the rhetorical power of fMR images in showing these places in the brain where this stuff happens. So it seems to me that there's actually considerable continuity in the way, well, just in the computer metaphor and the fMRI. So I was wondering what you thought.
I guess you're right, and I should just add as a word of caution that it's obviously always wrong to generalize in this very broad and sweeping way of saying that this was the metaphor, now it's over and we are on to that. So the immediate question would be, to what did this ever apply, and what do you really mean by that, talking about which segment? Though I would want to defend that something has been replaced, definitely something of the visibility as the stand-in for of the computer as a stand-in for the brain, in not just popularized version of the neurosciences, but in communicating what the brain is. Though, for example, the example I showed with the joke with the engineer, the very point of the paper was that, yes, in fact, fMRI matches exactly the specification that linguists have worked out on basis of their analysis of language competence, the difference between phonology and semantics. Now, this is not just a deeply ingrained difference in human culture, but this is a difference in brain activation, i.e. physiology. So they obviously are, I mean, this was one thing, they're all obviously, as you say, a crossover. I think that's a very nice way of phrasing it. Also, certainly, modeling still goes on in there. I mean, all the functional imaging uses model of X, model of Y, that goes into the cascading, and yet this is an understanding of model and of modeling that is miles away of the function of a model as mirror of humans' nature. So.
I mean, surely one way of thinking about it is that now fMRI has come along and shown us the truth about the hardware, where before we could only come up with a kind of what the results were, the input-output software programming, right? So in fact, you could see it not as a change, but as a continuation or a fleshing out of the computer metaphor. Now we can see the underlying hardware. And I would have thought, again, you still get that language in fMRI. So
although I would, there probably, that could be a point that we would really have to debate, because with fMRI, we are back to structure and topography. Whereas, and thereby away from the strict functionalism of the computer model. That was the big thing of the computer, was that everyone knew from the start that biological brains and computers had no resemblance whatsoever with regard to the technical components that went into them. And we are now looking for something that brings structures and structural similarities much more into focus with fMRI.
Well, actually these questions just prompted me. I think I should say a few words about neuroscience, although there are probably better people here to speak to that. But I want just to point out that actually imaging is not all neuroscience. Neuroscience is more than that. What neuroscientists try to do is we are trying to understand how the nervous system works, and there are many different approaches we take. fMRI became very popular because you can show nice images, but indeed it is very much discussed and very well known that there are problems. There's a lot of, on a much smaller scale where we have made a lot of progress. What we want ultimately to do is to connect these mechanisms, which we know on a molecular level, for example, to relate it to the behavior. And fMRI will be one tool to say at least, okay, there's actually some correlates. And there are many problems with this method. But we have made a lot of progress. And I don't know, people who are interested in how the brain works, they're all neuroscientists, and we should, bring different methods to the table. So my question would be how humanities actually helped in the last, say, 100 years to help us to understand what the, how the brain is working. And, metaphors are always problematic. The brain is not a computer. In particular, when we think about the von Neumann type digital computer, we know very well that, that our brain works very different. We have actually very good theories now. What is important, how this memory model works, how we make predictions with it. Decision theory is actually, or decision making is now widely debated area in neuroscience. So I thought I just should speak up a little bit that actually neuroscience is a little bit more than just these pretty pictures.
That was exactly my argument. 15,000 neuroscientists around the world are damn good at making the brain ever more complicated, not speaking in one single language about the brain. I can't help but using my own single voice in talking about the brain, but you're absolutely right. It's the neurosciences that are really the center of productivity here. That's the core of the argument. There's an enormous potential in the neurosciences. That's, by the way, also the reason why I'm very, very skeptical of your account of any ultimate picture there. And I think I brought forward some at least sincere, but hopeful also at least partially convincing argument why such a completion of the picture is exactly not what we should strive, what we want to have. We should strive for. But, because that keeps our culture going, and that's the fun part. But the door has to be kept open.
I had a question about some of the ethical or social implications of your overall push back towards seeing a hubris in thinking that we are very close to breaking a barrier of understanding brain activity as mind activity, and that it's much more complicated. And a number of neuroscientists have been very active in actually moving against certain other neuroscientists that are getting more and more media attention. I'm thinking of the Nature news piece this week on a number of neuroscientists going around imaging the brain activity of psychopaths, while their defense team is actually seeking any kind of evidence whatsoever to mitigate the sentencing of the death penalty. You have a number of other neuroscientists pushing back and talking about how this is racing far, far, far ahead of anything that can be concluded about, and I put in scare quotes, the abnormality of the so-called psychopath. And I'm just wondering, one of the roles that those of us in the humanities can play as we co-create a space together that recognizes the complexity of what we're talking about is trying to talk about social responsibilities, so the communication of scientific results in a way that resists the cliched and sloganed aspects of what you get in mind-reading journalism headlines. And Nature, I think, was trying to set this up, and I just wondered, do you have any advice to those of us in the humanities eager to help our colleagues in the neurosciences adequately communicate to the public as well as science journalism that they need to take greater care in their reporting of what is in fact being discovered within the relevant neurosciences?
First of all, your question invites me to also react to your question, also that I'm painfully aware of that functional neuroimaging is not all, and also that a particular habitus or stereotype of the boisterous statement-making neuroscientist is certainly not what I've encountered while I was doing lab work. Though I do think that there is a tendency within visual functional imaging seducing people and prominent people in that game into taking these very public roles. So that is one thing I think social scientists, humanities scholar should talk about. On the other hand, I obviously have also to question myself how I'm rather enhancing that if I'm lumping together the neurosciences on functional imaging in such a talk, for example. The other more imminent, because it's back on our turf, implication would be to really insist on the competencies we bring to the table that are our competencies and our expertises, and that come with their own measures and indicators of success. I think that is almost tragic when in a field like education, for example, we think it's better evidence when we have brain data that young kids learn foreign languages quicker than adults. What is that evidence for? It may be very useful in understanding the brain and language competence, but we don't need this neuro evidence for our deep, well-proven empirical evidence that kids, yes, pick up foreign languages better than us adults. So, pushing it and being confident about the differences of scientific endeavor. So I think that would be the first thing. And the other is, and perhaps the third, because obviously the entire legal system, the legal realm will be affected some way or the other by neuroscientific evidence, and there's a long history of medical circumstances that should have consequences in the court. I guess the responsibility on the social scientist is here to make clear that social relations are always more than just what's going on in a single brain. That social relations, by the very concept of what we mean thereby, is something that is intersubjective, that only occurs in societies that keep certain sets and rules going, that keep the realm of the intersubjective space alive. So there's obviously complexity there that can't be easily taken away and being dissected with the approaches that are currently available, even in social neuroscience.
My question is about the current metaphors of the brain. And it seems to me in popular culture, I wouldn't say an aesthetic culture because I haven't seen it visualized yet. And I'm an artist, and the visualizations of metaphors are of great interest to me. But it seems to me that the computer metaphor recently, I'd say in the last 5 years, has been replaced with the metaphor of plasticity. The brain as plastic, the brain as in the brain repairing itself. That idea that no matter what happens now, our brain will grow new cells. And I haven't quite seen a visual image of it as we've seen hardwired with wires and things, but I'm just waiting for the clay image to come about. But I'm wondering if you could speak a little bit about this new metaphor, if you agree with it or not, or in other words, that it is a metaphor in our culture, and what you think of that.
Perfect last question. It's absolutely amazing, fascinating, and scary because we just enter a regime. The guiding idea is neuroplasticity at a moment when we increasingly live in virtual and augmented reality and have the devices to interfere with our mental life in real time. So it's not only that we have the tools to change our mental life, we are now even conceive of this being actually the very basis, the very nature of our brain. So happy gaming.
Just before you go, I'd like to introduce the brain of this organization, William Barker, who is the president of King's, to give some thanks. William Barker.
I'd like to thank the speaker very much, Dr. Borck. I was fascinated to see how the one metaphor can displace another over time that way. And I was thinking about this, I'm an English professor, so I'm thinking, metaphors, you know, they extend our thought and at the same time they overwrite experience. So you got this kind of problem of metaphor that both leads you out and can trap you. And then when we got to Freud, suddenly we were changing directions because now we're moving into narrative. And so what you have really is a much more complex model than the single metaphor. You've got a narrative way of looking at experience and of the way the brain works. And that to me seems probably more and we're talking about plasticity at the end. I thought that seemed to me really where we're going with this. And of course, like, narrative, life narrative, Aristotelian narrative, you know, has beginning, middle, and end. Life narrative does not have beginning, nor does it have an ending. It just keeps going. And so I think that's my takeaway. Thank you very much. And I would like to thank Dr. Borck very much for an excellent presentation. Thank you.